Okay, so hello everyone. Today we will be discussing Leetcode's Biweekly contest 119, which was held today. So let's start. So this was the first question. So you are given two arrays, num1 and num2, and we needed to. It was just a brute force. Okay, it was just a brute force. So what we needed to do? So we needed to calculate such indexes in first array such that it is occurring at least once in second array, and the number of indexes I in the second array. So basically, uh, let me explain you this. This is just an implementation. So consider this is the first sub array, this is the second sub array. So uh, as you can see, like the elements at indexes 1, 2, and 3. Okay, they it had occurs at least once in nums 2. So at these all values, like 3 was occurring here 3 was occurring in the second array. Similarly, the number 2, it was also occurring in the nums2 at least once, and number 3, okay, this is also occurring at least once in this array. So we needed to count all these, how many indexes are there, and push that into our answer vector. Similarly, we needed to do it for the second sub-array. So for example, if 2 is here, if 2 is for a particular array, if that value is present in the first array, and I need to push that index. So it was just an implementation. You can just go through this because like this was an easy problem. So what did I do? I maintained a set. Like, okay, you there are multiple ways, but this was the first way which I thought could have thought of. So that's why I implemented. And like since the constraints are very too low, so I did not care of time complexity much as well in the contest. So initially I pushed the set all the elements in the first vector and the second vector in the set one and set two. Okay. Now f- just did what the question wanted to say. I maintained a count variable, and for every value in the first value array, if that is present in the second set, so I incremented my count value and I pushed how many times it occurred. So in my answer vector, I pushed the number of count, that how many elements it appeared in the second array. And for this, and similarly, I did it for second array and I pushed it. So this was an very easy problem. So I hope you got this. Let's now move to the second problem. So okay, so in this is also an easy problem. So in this problem, you would be given a string word, and you could change word I to any character, and you need to return the minimum number of operations such that you can remove all the adjacent almost equal elements. So what are almost equal elements? So for example, these two characters are there. Okay, so a character x. Okay, for these x, the almost adjacent elements would be elements character would be the first the particular number itself x, second y, and third w. Okay, like w, x, y, z. Okay, so in the dictionary order or in the alphabetical order, this for this x, w, and y, these all would be almost adjacent on the number itself. So these all are adjacent characters. Okay, so what you needed to do was, if a particular string, you in a particular string you needed to maintain a minimum number of characters, and you needed to change minimum number of characters such that if you select any two particular adjacent characters, it should not be almost same. Almost same is the definition which I mentioned here. So how would you do this? So just think, okay, if this is an array, if this is an array, I mean it's a string. I'm just representing the form of an array. So if this is an array, Then imagine that this element is adjacent to this element. For so let's say this element is let's say C. So imagine this is D. Now imagine this D, it is similar to next element, which is let's say D itself. Now this is let's say similar to adjacent to E. Okay. Now E, it is similar to Z. Okay. Now for this, you tell me what would be the minimum number of steps. So for this, C, D, D, E, Z, can you find that this is linked to C is linked to D, D is also linked to D, and D is linked to E. So these is all is forming a group because E is not linking to Z. So if you apply some changes in this group, because it would be only required, you would not be required to change any Z or E because for interaction between E and Z, because these all have to be distinct for having in particular two groups. So uh, C, D, D, E. If this is all the case, so for imagine I have four length letter. So what would be the minimum number of changes that my whole array is distinct? So obviously I would, since I need to minimize, I would try to change this and this value for second and last. Why? Because it would also affect this second and first and third value, and this last value would also affect this and this value. But since my next value it is obviously different, so I don't need to care. But till now, if my length is, if my n is even, okay, I need to make at least perform n by 2 operations. And if my length is odd, let's say 5, then here also I needed to at least maintain n by 2 operations. So at max, at any case, I need to perform n by 2 operations, okay, to make the changes. So yeah, this was just the approach. So what did I do? This is my implementation, that I maintained a pointer I, okay, and I maintained a second pointer j, which would be starting from I plus one, and I would uh, I would just a second, guys. So just a minute. So what did I do? I maintained two pointer I and j. J pointer would extend till how much like this particular group would be formed, and I just calculated the length by j minus I, and at least I need to do n by 2 operations, so I implemented in my answer. So this was also an easy problem. So let's move to the third problem. Length of the longest subarray with utmost k frequency. This is pretty standard problem. Okay. What we need to do, we needed to find an subarray, okay, such that each element in that is less than equal to k, okay, and we needed to find the longest good subarray. So as we like as we did in a two pointer approach, the same concept. So for every index I, let's imagine we are standing at this index. For every index I, we needed to find what, the length of the longest, like we would try to find the length of the subarray such that every element is less than equal to k in this array. So we will try to shrink the j pointer from the backs, such that it is every element in this is less than equals to k. So imagine that how do you now extend or shrink the array, right? So imagine for a particular instance that for this I pointer, you know that this j pointer is a valid one. So this means for every element in this is less than equals to k. Now try to calculate for this ith index. So when you try to find for this ith index, if my value it is exceeding k, so that is obviously going to exceed for this element as well. So you need to shrink this j pointer such that this element is found before it and it is excluded at least one. So maybe you found that this now j pointer shifted to this and this is my subarray such that it is valid. Now similarly you would proceed for this ith index now. Okay, so imagine that you are calculating from this ith index. So obviously one more thing, like you can't you are sure, right? Because for this ith index j would be starting from here at least, like two cases can be here: a value which is not equal to the maximum element and a value which is equals to maximum element. Okay, so if my value is maximum element, I need to shrink as I did previously. But if it is not, okay, I cannot extend it backwards. Why not backwards? Because if I extend it backwards, like my possibility of my maximum value greater than k, okay, that is going to be invalid. For every ith index, we are going to find the maximum jth index as that sorry, minimum jth index, because I need to find maximize the length. Okay, so we need to find the minimum jth index as that my subarray every element in it is less than equals to k. Okay, so I initialized a map initially, and for every element I incremented the map counter, and while map at that, so that is meaning that value, the frequency value at that index that is greater than k, then I try to shift by decrementing the uh, value at that position. And what is this statement? This statement is basically saying that if, for example, if my map was containing 3 and it occurred once, so after this I would do it 0. But my since I need to remove it from the map itself, okay, I erased it from that map. So to just completely erase, I could have also omitted this line, but for making it logically correct, I did this and incremented the j pointer. At last, for every I calculate what is the maximum j length j pointer which I can get, and I calculate the answer. So this was the third problem. So let's move to the last problem. Last problem, yes, this was an little bit. It was just a totally algorithmic base and little bit like it was a mix of or not bit masking, like power set method which we generally use to calculate all the elements, all the subsets, and then use an algorithm which I will tell you. So you can just read the question in the meanwhile. So I hope you got the question. So question was stating that you would be given basically a graph, okay? And how would it given it? You will be given a vector of vector such that like it is telling from node 0 to node 1. From node 0 to node 1, my road distance, this length is 2. Similarly, from node 1 to node 2, my distance is 10, and node 0 to node 2, the distance is 10. Okay, so similarly, like this is how you would be given a graph. Now, it is telling that for a in the particular graph, okay, how many how many possible subsets, like basically how many nodes can you delete such that after deleting the existing nodes in the remaining graph, maximum distance between any nodes that is less than equals to maximum number which is given. I guess it's given here. Okay, yeah, maximum distance. So for example, imagine that this was a graph. Okay, let me do beta graph. Imagine this were the edges, and this was also a part of the graph itself. So think that you are trying to just maintain 1, 2, 3 and 4. Okay, you are deleting this fifth node. Okay, this fifth node. So if you delete this fifth node, okay, if you delete this, these all connections have, you have to think that it has vanished, and the remaining nodes which are present in the graph. So the maximum distance between any of the two nodes, it should be less than equals to the maximum distance which is given. For example, like let's say assume this is distance is 2, this is distance is 10, and this distance is 8, and maximum distance given is, let's say, 5. So till now, like if maximum distance would be, obviously in this case would be between 3 and 2, so this distance is 2 plus 8 plus 2, which is 20, which is obviously greater than max. So like this is not a particular method, like you can't divide it, you can't have let go this node. Okay, so if this is not the case, so if you would have been able, for example, if this value would be 1, 1 and 1, then you could have said that after deleting this distance between any two nodes, like maximum distance between any two nodes is, it is less than equals to the maximum distance is given. If that is the case, I increment that particular method of dividing, and at last return the answer. So how would I do this? So since n constant was too low, n was just less than equals to 10. So what did I do? I just counted, tried all the possibilities of to all the subset, tried to calculate all the subset which was of order of 2 to the power n. So now the question remains, if I'm able to, so for a particular combination like this method, okay, I will just give you a brief like how this masking of this working. So basically, I for if a number is, let's say, 3, okay, so I generate all the numbers. I generate 1 0 1 2 3 4 5 6 7 up to 8. Okay, now how would imagine that you have represented in binary form, so it would have like been this 0 0 0 1 0 1 0 0 1 1. Okay, in the binary format, then it would have been 1 0 0, then 1 0 1, then 1 1 0, then 1 1 1. Okay, these are all binary formats. Now uh, okay, imagine that you are trying to, basically, like this is a method how in which you can efficiently calculate the subset. So since array was of size 3, right, these three elements were there in the array. So now my what this is, one is representing that this first position and the last position. Okay, last position, if my these all are, if these all are included in my set, then what are the possible combinations which I get? So since in this exam, in this question, we needed to find that if I remove these some nodes, and if I removed some nodes and the remaining, if I removed suppose these nodes, then the remaining nodes, the maximum distance. So what is the what would be the maximum distance? So for that, I what did I do? I for in this case, I told that these all elements, if it would be not there, then what would have been the case? Okay, now once I figure out that out of five, let's say five nodes, only three nodes were there, then how do I find the maximum how do I ensure that maximum distance between any two nodes, it is less than equals to k or not? Like how do I check? So there is exists a very popular algorithm known as Floyd-Warshall algorithm. Floyd-Warshall algorithm. Okay, what is this Floyd-Warshall algorithm? It basically finds the minimum distance between any two nodes. Okay, it finds the minimum distance between any two nodes in the order of vertex to the power 3 complexity, vertex cube complexity. Okay, so here n is the number of nodes, n was here as 10, right? So here in order of just 1,000 complexity, order of just 1,000, we would have known what is the minimum distance between any two. But yeah, just this was just the case, and we just needed to simulate it for all. If we remove, like for example, if these all were the nodes, correct, if these all were the nodes. Now for example, if my one is this, so I would think that my this first node is not there, then what is the maximum distance between these all remaining nodes? So what did I do? I first constructed a graph like this, and if I'm telling that, for example, this node is not present and this node is not present, then I what did I do? I just for in all the neighboring roads which are connected to it, I initialize it by the maximum value, let's say 1e9, signifying that I would not be able to reach that node. Okay, in this way I modified the graph, and I just this is just particularly Floyd Warshall algorithm, total Floyd Warshall algorithm. I will not go into detail, you can just google it on the net how this is working. But this finds in vertex to the power cube complexity of how what it would be the minimum distance. Okay, so let me just show you how is my code working. So initially I uh, took my graph here and initialize the graph. Then since actually I initialized file first the in this I actually took an n cross n, like in what we do initially, we usually do with input adjacency list, correct? We in usually input adjacency list, but here since n was very low, I took an adjacency matrix because it would be easy implementing this Floyd Warshall algorithm. So initially I said in every value is to be infinity. Here I mean infinity to be 1e9. Okay, so that's how I initialize. Then infinity, infinity, all these values. And at the end, once I input all the values, which would be overwritten here, okay, which would be, let's say here x would be there. Then I also know that the so what does this node is signifying? That distance between 0 to 0 node is infinity, which is incorrect, because for a particular node you could reach in 0 distance. So just for all these values where I equals to j, I initialize it with 0 value. Then I calculated for all the mask 0 to n to the power n minus 1. And if my particular bit is set, for example, this would be the marks. So first, third, fourth, and fifth, if these all are set, I told that I initialize also visited value. Visited, it means that these all are present in my nodes. So since in this one is signifying this has to be excluded, so I marked all these as false, in which one were present. Okay, in which one were present, I marked all these as false. And I, the adjacency list, I in the adjacency graph, I made this as 1e9, and I also made a copy so that my original graph is not affected. I can do this like because my space would be very low, right? N cross n, that's equals to 100, just 100. So that is very good enough. And at end I just call the Floyd Warshall algorithm, and if my value for that particular arrangement 101 for, if imagine for this particular element, if my maximum distance between any two nodes is less than the given distance, I just incremented that and I returned that answer. This is just the Floyd Warshall algorithm, and in this I'm calculating what would be the maximum distance between any two nodes. Okay, if that node is present, so that's why I use also visited array. So yep, that's how it would be then. And so total complexity of this algorithm is basically, for this masking, it would be order of to the power n times. For every time I'm let's say initializing this, so it is n cross n, n cross n for copying the graph, okay, and send in making all the changes. And for Floyd Warshall algorithm, it is of order of n cube. So overall, it is order of to the power n into n to the power 5. Now here n is very low, 10, only 10. So it is order of to the power 10 into 10 to the power 5. Okay. So which is approximately order of 10 to the power 3 into 10 to the power 5, which is approximately order of, in the worst case, 10 to the power 8, which will surely work. Okay. So this is how the last question was there. So I hope you got the explanation. So thank you for joining.